Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Now we are going to discuss the human eye. The learning outcomes of this lecture are the human eye accommodation, near point and far point, defects of vision, nearsightedness, and farsightedness. The human eye. Human eye acts just like a camera. In place of film, the retina records the picture. The eye has a refracting system containing a converging lens. The lens forms an image on the retina, which is a light sensitive layer at the back of the eye. As you can clearly see in the picture that an object is placed in front of the eye and the light rays emerging from the object entering the eye lens and forming an image of the object on the retina. Also, in camera, the distance of the lens from the film is adjusted for proper focus. But in eye, the lens changes the focal length itself. Light enters the eye through the transparent membrane called cornea. In the human eye, the iris is a colored portion of the eye and it controls the amount of light reaching the retina. It has an opening at its center, as you can see in the figure, called the pupil. The iris controls the size of the pupil. In the bright light, iris contract the size of the pupil, while in dim light, pupil is enlarged. The lens of the eye is flexible and accommodates objects over a wide range of distances. Accommodation. Accommodation is basically the variation of the focal length of the eye lens to form a sharp image on the retina is called accommodation. Basically, in this topic, we are going to discuss that by nature, eye lens can change its focal length automatically and it will instantly focus the far object and near object by changing the focal length of the lens. Whereas in camera, focus the image of an object at a given distance from it by moving the lens forward and backward from the film. The eye has different adjusting mechanism for the focusing the image of an object onto the retina. In this, ciliary muscles controls the curvature and thus the focal length of the lens and allow the objects at the various distances to be seen clearly. Now we are going to discuss the accommodation for distant objects for the eye. If the object is far away from the eye, the deviation of the light through the lens must be less. In order to do so, the ciliary muscles relax and decreases the curvature of the lens. Hence, this increases the focal length of the eye lens. When the focal length of the eye lens increases, the rays are focused on the retina and produced a sharp image of the distant object on the retina. As you can clearly see in the picture that a distant object is placed in front of the eye, the light rays emerging from the distant object entering the eye lens and then refracted and forms a sharp image on the retina. Accommodation for the near objects. If an object is close to the eye, the ciliary muscles increases the curvature of the lens. When the curvature of the lens increases, it will shorten the focal length of the eye lens. So, all the divergent rays from the near objects are thus bent more so as to come to a focus on the retina. As you can clearly see in the picture, that an object close to the eye lens is placed in front of the eye lens. All the light rays emerging from the head of the object entering the eye lens, refracted and converge on the retina or focus on the retina and forms a sharp image on retina. This accommodation is going to be decreases with the age of the people. It is large for the young people, and with the age it will decreases. We can overcome this defect by using different types of lenses. Now we will discuss the near point for the eye. The near point of the eye is the minimum distance of an object from the eye, at which it produces a sharp image on the retina. This distance is also called the least distance of the distant vision. An object closer to the eye than the near point appears blurred. As you can clearly see in the picture, that for a human eye, the near point is located at 25 centimeter from the eye. It increases about 50 centimeter at the age of 40 years and to go roughly 500 centimeters at the age of 60 years. The far point for a human eye is the far point of the eye is the maximum distance of a distant object from the eye on which the eye is going to be relaxed fully and can focus the far objects easily. A person with a normal eyesight can see the objects placed very far away, such as the planets and the stars, and thus has a far point located at infinity. As you also know that during night we can see the twinkling stars and we can see the planets also, but we cannot sometimes distinguish between the stars and the planets, but we are able to see the distant objects which might be placed at infinity. Defects of vision. This is the inability of the eye to see the image of the objects clearly is called the defect of the vision. The defect of vision arises when the eye lens is unable to accommodate effectively. The image formed are therefore blurred. The eye lens might be not able to focus the far objects, or the eye lens might be not able to focus the near object. There are two types of defects in the eye. One is the nearsightedness, or it is known as myphobia. Some people cannot see the distant object clearly without the aid of spectacles. This defect of vision is known as short-sightedness or nearsightedness. As you can clearly see in the picture that a distant object is placed in front of the eye and all the light rays coming from the object after refraction from the eye lens are not able to produce the image on the retina. Instead of producing the image on the retina, it forms the image of the object in front of the retina. It may be due to the eyeball being too long. Light rays from a distant object are focused in front of the retina and a blur image is produced. Now, how do we correct the nearsightedness? Nearsightedness can be corrected with the glass or contact lenses that use diverging lenses. Light rays from the distant object are now diverged by this lens before entering the eye. As you can clearly see in the picture that a diverging lens is placed in front of the eye, and after placing the diverging lens, all the light rays are clearly focused on the retina and a sharp image is formed of the distant object. The second defect of the eye is farsightedness. This is the disability of the eye to form distant images of the nearby objects on its retina. It is known as farsightedness. When a far-sighted eye tries to focus on a book held closer than the near point of the eye, it shortens its focal length as much as it can. However, when at the shortest, the focal length is larger than it should be. Therefore, the light rays from the book would form a blur image behind the retina. As you can clearly see in the picture that an object is placed at the near point of the eye, and all the light rays after passing through the lens focus behind the retina. So it makes the image blur. Farsightedness can be corrected by using suitable converging lenses. The lens refract the light rays and they converge to form an image on the retina. These rays appear to come from the near point to form a sharp and visual image on the retina. As we can clearly see in the figure that an object is placed in front of the eye, and when we place a converging lens between the object and the eye lens, after refraction from the converging lens, all the light rays are focused on the retina and formed a sharp image on the retina. But this image is virtual in nature. In this way, we are going to correct the farsightedness. Thank you so much for listening the lecture.